time on that during the weekend and get it back to you as quickly as possible. I don't know if that'll be early next week or middle of next week, but I want to get it back to you while that stuff's still fresh in your mind. And when I do, we'll go over the solution together in class. So get a chance to just kind of assess how things go on the test. So I've just loaded a new homework assignment onto Blackboard. It's homework number 6. There are 4 problems there. One is a short answer plus 3 problem solving. One of the questions is related to, well, 2 of them are, one of the problem solving and the conceptual question is related to today. And then the other 2 problems are related to material that we'll go over in class on Friday. Then the other announcement to just remind you about is the project. And I know that some of you are making good progress on that because I've gotten a couple of questions so far. So as you work on it, just let me know if you have any overall conceptual questions. I don't yet have the solutions with me, so if you've already calculated and want to check your answers, I can't help you out with that today, but if you wanted to stop by my office sometime or send me an email, then I'll be able to assist you with that. Are there any questions related to the announcements? Yeah, homework 6 has 4 problems. Yeah. It'll vary. There's no rhyme or reason. It's mostly broken up by like just the amount of material, holidays. Yeah, I don't find it possible to always stick with a certain day of the week, but this one will be due by noon on Monday. Other questions? All right. So I've already told you a little bit about the rate of return and what it is and how to calculate rate of return. But we're going to go into that in more depth today and discuss how we can use the rate of return for decision making. Because remember, at the heart of this course is the notion that as engineers, we need to make decisions based on maximum efficiency. So when we choose alternatives, they should be the alternatives that will generate the most profit or minimize the costs. And so internal rate of return analysis is a valuable tool for initial screening, but sometimes we need to be a bit cautious when using it to make decisions. And so I'll tell you all the warnings and advantages of internal rate of return analysis today. So just to begin with an illustration, I recently pulled up the auto loan rates for 2 different lenders. And I'm sure that if you've borrowed money recently, whether it's mortgage or auto loan, or I think even maybe student loan rates have gone up, you'll notice that the borrowing costs have gone up in the last year by quite a lot. So what this auto loan rate table shows is that, number one, they charge more for older cars to be financed than they do for newer cars to be financed. And so does anybody have a speculation on why that would be? Why a bank, in this case Huntington Bank, why would Huntington Bank charge a higher interest rate on to finance an old car than a newer car?
Lower principal.
Lower principal?
Lower total cost.
Okay, so you're thinking that the older car costs less, and so to make it worth their while, maybe they want a higher interest rate. And I think there's a certain logic to that. Keep in mind, though, that when a lender makes a loan, that they have loan origination fees that are a flat rate in addition to the interest that you pay. Yeah.
I think an older car is less dependable, so they want to, has more of a risk of maybe someone defaulting on it if the car breaks down.
Okay. Yeah, remember that at the core of one of the main things that banks want to be compensated for when they lend money is risk, whether it's interest rate risk or default risk. Default risk is really important to lenders. And so think about, is there a difference in default risk on an older car versus a newer car? And so I think what lenders sense is that when you have an older car, maybe there is a greater risk of it breaking down. And some people are just going to walk away from a car that maybe has a seized up engine and they can't afford to fix it, and so they just let the company repossess it, but then the mortgage, the lender who repossesses it isn't able to get their value back because the car is so badly damaged. So there's maybe, it's a safer investment for the lender to finance a newer car than it is an older car, because the newer car would be under warranty. So if the engine seizes up or it has some sort of a malfunction, then maybe the borrower can still afford to get it fixed and continue to make their payments rather than just turn their back on the obligation and let it be repossessed. So that's my interpretation of why the interest rates increase as the model year gets older. So let's compare Huntington Auto loan rates to PenFed, the Pentagon's credit union. And for them, their 72-month loan rate is 5.84%. And I took these on, this was back in February, but it was on the same day that I screen grabbed both of these interest rates. So it's for the same duration, 72 months, and the same model year, new car, 5.84%. So what we're going to do, just as an illustration, is look at what if you were going to buy a vehicle and use it for work. You wanted to generate some additional revenue by having some equipment that would allow you to get to more customers and bring in more business. What would be the impact of the higher interest rate versus the lower interest rate? Okay, so to investigate that, let's look at this 2023 Ford F-150. And it's always shocking to me how much trucks cost. Everybody around here has to have a four-door truck, and they cost as much as $100,000. This isn't even the most expensive truck that I was able to find, but it's expensive enough, $86,000. So let's say the hypothetical here is that you're buying this as a work truck, and your estimation is that you could generate an additional $1,500 per month in new revenue if you bought the vehicle. And so what we mean by this is like taking into account the cost of fuel, operating costs, insurance. This is new revenue that is going to go towards the capital recovery of the vehicle. So should you do it at 5.84%? Should you do it at 8.35%? So I think Excel is a great way for us to kind of tackle this illustration. And let me just copy the particulars from the problem statement over to Excel. And if you'd like to follow along, you can, but this isn't an illustration that will directly be part of the homework. So this isn't one of the critical ones. Like on Friday, I'm going to do some demos that are critical for you definitely to follow along. This isn't one of those. So we're going to do the interest rate per year just to start off with, because that's how it is quoted, is the interest rate per year. And it's actually, the door is closed. It's so noisy, I thought the door was open. All right, so the interest rate per month, because that is the period duration in this problem, since we know the new income that's coming in on a monthly basis and the loan payments occur on a monthly basis. So the initial cost of the equipment and then the monthly revenue. All right. So what we have for the interest rate per year, for this first part of the illustration, it's suggested we look at 5.84%. So 0.0584. And now the interest rate per period will be that amount divided by 12, because there's 12 months in a year. And the initial cost of this vehicle is $86,645. And then the additional revenue we can expect each month is $1,500. All right. So what I want to look at here is the month, and then the amount, and we'll look at the present value of the amount. So starting at time 0, where we purchased the vehicle, and going all the way through, this is a 72-month loan. It's a long time to be making payments. 72 months. There we go. All right. So at time 0, we have an outflow of $86,645, and then at all of the years after that, we have an inflow of the monthly revenue amount. So I'll just distribute that down. So we've got an outflow and an inflow, and just so it doesn't drive me nuts, let me format that as currency. All right. So the PV of amount. So we want to find out, for example, what is going to be the total present value of this project if we have this low interest rate. So I'm going to find like the total PV here. I'm not going to do it at the bottom this time just because I don't want to be scrolling up, down, up, down. So I'll find the PV in each individual month. So PV of this interest rate per month will be the applicable interest rate, and I anchor that because I'm going to be dragging the formula down, and I always want it to look at this interest rate per month. The NPER is how many periods in the future is the amount in question, and how far does it need to be discounted to get it to the present. So if it's already at the present, like in our 0 time, it's not going to make any change there. And then I'll do double comma to skip over the payment field, and the amount in question will go into the future value field of the function. Because we're treating each one of these future $1,500 revenues as a distinct single amount that we want to discount to the present. Okay, so there's no change for the amount that's already at time 0. And when I calculate, what you'll notice is that the present value of these amounts keeps getting lower and lower and lower because $1,500 72 months in the future isn't worth the same as $1,500 that's just 1 month in the future. 72 months in the future, where each month that amount is being discounted even by less than 1%. If you look at the interest rate per month, it's about 0.5% per month. But over the course of 72 months, what that means is the value of your new revenue at the end of this project life is much smaller in present terms than the $1,500 that you're getting in this 1 month after you purchase the vehicle. Okay, so now let me add it up. I'm going to do the sum function of all of the PV of the amounts. And so I'll do Shift, Control, and the bottom arrow, and that takes me to the end of the list. Just a little keyboard shortcut there, rather than having to do, equal sum, and then clicking and dragging and hoping that you time it just right. I mean, that works okay, but another way of doing it, rather than clicking and dragging, is you start on the first cell that you want, you press the Shift button, Control, and then the down arrow, and it'll go to the bottom of the list and stop. So this is a profitable project. So what's our interpretation here? If the annual nominal interest rate is 5.84%, then the project is profitable. 4278 is the PV of the profit. That means, like, you're going to be having to make interest payments on this, and you're having to pay off the principal of the vehicle. So when you pay for the cost of the equipment, there's going to be some leftover money each month that you get to keep. So the $1,500, some of that goes towards the vehicle, some of it goes into your pocket. And so the portion of the money that you get to keep has a present value of $42.78. That's the present value of all those future revenues that you'll be making by getting this vehicle. So if we were applying present worth analysis, we'd say that's above 0, we should proceed with the project. We don't know what our MAR is. Remember, minimum attractive rate of return? If the MAR was 6%, then we'd have to do a different calculation. And that's what we'll get into today with internal rate of return analysis. But here, just applying present worth analysis, since it would be greater than 0, then that means that the project is profitable. But this was at our interest rate of 5.84%. So this illustration asks, what if we had to pay Huntington Bank rather than Penn Fed? So what if we borrowed the money at 8.35%? It seems like it wouldn't matter because it's not even 3% difference. It's less than 3%. You'd think, well, 3% isn't very much. But let's just check that to see. So I'm going to change the interest rate per year to 0.0835. And it's automatically going to calculate the new interest rate per month. Now the initial cost and the monthly revenue will stay the same. But all of the calculations row by row are going to be different because now those future amounts are being discounted at a higher interest rate. So think about what this means. If you've got a higher interest rate, it means that those amounts in the future don't have as much value as they would at the lower interest rate. And what you have in the future is money coming to you. You've got revenue. So the revenue is going to be smaller than it was before because it's being discounted more heavily. That's one way to think of it. The other way to think of it is, remember that this present value represents how much money you get to keep after paying back the bank. If the interest rate is higher, your car payment will be higher, and so less of that future revenue gets in your pocket. And so let me type enter, and it'll do the updated calculation. So you'll notice now it's negative. So our revised interpretation here is, let me put it on the row above just so I don't lose what I've typed already. If the annual nominal interest rate is 8.35%, then the project is not profitable. So what it means is you'd buy this truck and you'd be putting it into use, trying to generate new revenue, but the new revenue you generate doesn't cover the cost of the vehicle and the interest costs. So that would be a thumbs down. You shouldn't do the project if you have these higher borrowing costs. So whether it is someone who's deciding whether they should buy an investment property, like a landlord who's wanting to buy a house and rent it to students, if they have to borrow money at a higher interest rate, it may not be worth it to them. It may not be a profitable investment if you have the higher borrowing costs. And so borrowing costs matter. This is just an illustration of a project that could be profitable or could cost you money depending on what interest rate you have to pay. So are there any questions or observations about that illustration? All right. So interest rates matter, and the internal rate of return method is that what you should do is you should find what interest rate makes it where the present worth of the revenue equals the present worth of the expenses. So the formula here for finding the internal rate of return, the formula is that all of the revenue gets taken to the present at some interest rate, all the expenses get taken to the present at some interest rate, and the unknown interest rate you're solving for here, I prime, should make the revenue and the expenses equal to 0. So that's how you know what the interest rate is it's that unknown interest rate that brings balance between the inflows and the outflows. So as a graphical illustration, when the interest rate that you use is too low, somebody's having a bad day. All right, when the interest rate is low, it'll give you a positive present worth, and that's what we just saw in our example. Is we saw when the interest rate was 5.84%, we had a positive present worth. When the interest rate was 8.35%, we had a negative present worth. There is some crossover point at which the present worth goes from positive to negative, and that's what we're trying to solve in the internal rate of return analysis. We're trying to find out what interest rate would make the present worth of the inflows and the outflows equal to 0. So back to this illustration, I could keep changing this interest rate until the total PV is equal to 0. So let me move these previous statements here off to the side. All right, so now, what if what is the interest rate that makes the sum of the PV equal to 0? Well, what about 7%? That's too big. What about 7.5%? That's getting awfully close. And of course, rather than keying it in manually over and over again, I can go to the goal seek and tell it that my goal here is for this cell to be 0, and it should change the interest rate. So as it solves for the interest rate, it tells me here that for interest rate of equal to 7.54%, the sum of the PV of amounts is 0. In other words, the internal rate of return is 7.54%. So, like, if you bought this truck and you got $1,500 each month, it's kind of like what if you made a deposit into the bank of $86,645, and you were going to withdraw $1,500 each month for 72 months? The equivalent rate of return of that original investment would be 7.54%. So it's the interest rate that brings you from being positive present worth if the interest rate was too low, negative present worth if the interest rate was too high. It's the Goldilocks zone of just right. It's equilibrium between the inflows and the outflows. So the internal rate of return is the rate that's earned on the unrecovered investment balance, and we'll talk more about unrecovered investment balance on Friday. I think we've already kind of tackled the idea of the payoff period and those sorts of topics before, and this is very closely related. Another way to think about the internal rate of return is it's the rate that's being paid on the yet unpaid balance of borrowed money. So if you've borrowed money and there's a schedule of how much you have to pay and over how many months, the amount that you haven't yet paid back, you are paying an interest rate of the internal rate of return. So it brings all of the cash flows into balance, inflows and outflows at the present. And so the way that you calculate it, the method here, just as I've illustrated, all of the future values should be discounted to the present at some unknown interest rate, and you solve for the interest rate that brings the inflows and the outflows at the present to 0. And then that tells you the rate of return on the investment. So using this cash flow just kind of as an illustration, what if you had to buy some equipment at time 0? So you paid for the equipment at time 0, and then it gave you some immediate payoff in year 1, then nothing happened in the second year. In years 3, 4, and 5, you have to make some investment to refurbish it, but then it generates a series of inflows, and there are a couple more outflows. So if you wanted to find out what is the rate of return for this original investment, then the process you follow is you take any amount that isn't yet at the present, you discount it to the present using the PV function, and the interest rate that you're utilizing in the rate field of the PV function, you start off with a guess, and then you change the guess until the sum of the present values is equal to 0. So equilibrium between the inflows and the outflows. Now for decision making, we have to be careful. I already mentioned that there's kind of a warning associated with using internal rate of return analysis. Internal rate of return analysis is calculated on the basis of your original investment, and sometimes two different alternatives will have different costs. And so you can't just compare interest rates and pick the one that has the highest internal rate of return. And I think an example that will make sense to you is, what if you had the option, you have a big pot of money, you've got a lot of money, but you've only got 2 banks that you can put it in. One bank would accept a deposit of $1,000 and they'll pay you 10% per year, but they'll only take $1,000. Another bank will take $100,000, but they'll give you 8% per year. So what would you rather have? Would you rather have 10% return on 1,000, or would you rather have 8% return on 100,000? You'd make more money on the second option, even though it has a lower internal rate of return. Now, sometimes alternatives won't be that obvious. You won't be able to just look at a cash flow diagram and instantly know if this is one of those cases where the lower internal rate of return is maybe better. So there's a really important rule. The IRR should be used when there are revenues and where the revenues exceed the costs. And you can use Excel to solve it graphically, but the decision criteria is just only limited to whether you should accept or reject a particular option. IRR can never be used to identify which option is best because of the fact that different alternatives oftentimes have different initial costs. And so until you've done the full analysis, you may not know whether it's better to have a low IRR investment that costs more or a high IRR investment that takes a lower initial investment. So just think about that pot of money example. And so these are the decision criteria that you can be comfortable with. You can use IRR analysis for initial screening if there's multiple alternatives. It'll tell you if a project is acceptable or if it should be rejected because it will yield less than the minimum attractive rate of return. So just to reiterate one last time, it's okay to compare the IRR of a project to the MAR and then either accept or reject that project. And if you have multiple alternatives, it'll tell you whether to accept or reject each of the alternatives on an individual basis. But what you can't do is you can't compare internal rates of return for different alternatives unless the original investment amount was identical. Now, there's one more thing you should be aware of with IRR, and that is that the internal rate of return assumes that the cash flow that you're generating during the project's lifespan is being reinvested and is compounding at the internal rate of return. So you may have been wondering why it's called internal rate of return. So that word internal is talking about the reinvestment of whatever funds are generated back into the same project or a project that is yielding exactly the same rate of return. Now, some projects and some investment opportunities, that is possible. Like if you think about a savings account, the bank is more than happy to have you leave your interest in the savings account and it will continue to earn compound interest. And you've seen the effect of that. But there are some investment opportunities, like if you bought an ice cream store and you had some initial outlay of money to purchase the equipment, to purchase the ingredients, to refurbish the space. So it's going to generate revenue over time, but you may not be able to take the money from that revenue and reinvest it into the same store. You may have to take the money that you get and put it into a bank account or into some other investment alternative that has a different rate of return. So the internal rate of return, when you calculate it, it's assuming that the funds can be reinvested into that project or a project that yields the same rate of return. So we'll handle, like in a future class, we'll talk about what to do if that's not the case. On Monday next week, we'll talk about external rate of return. But internal rate of return is relatively easy to calculate, and it's got these restrictions and limitations. So does anybody have questions about the restrictions or the assumption associated with IRR? All right, let me hand out the in-class exercise for today. On the front side is some internal rate of return questions, and on the back side is a bond question. You didn't have a bond on the exam, but you will have a bond on some exam this semester. So I don't know if it'll be exam 2 or the final, but I think the ability to value a bond is really important. So I want to keep you sharp on that. So I'll throw these example bond calculations at you from time to time just to keep you fresh. On the screen right now, if you're stumped and don't know how to proceed, you can just follow along as I work through it. I won't narrate it, but I'll do the calculations. Okay, so before moving on to the goal seek, did everybody get 26,906 for the present value at 7%? Okay, and then at 8%, and then the present value is negative 15,000. All right, I see nodding heads, that's good. So the interpretation of that is if you see that the present worth is going from positive territory into negative territory, remember that graph, that figure. If you're going from positive territory to negative territory, the internal rate of return is somewhere between the two. If you wanted to get really nerdy about it, you could try like a linear interpolation, and that would get you pretty close to the interest rate, except for that it's a curve. It's not actually a line. So it would get you close, but it wouldn't get you all the way to knowing really, truly, what is the internal rate of return. So to do that, if we copy the spreadsheet just by right-clicking down here at the bottom, and then you do move or copy, and then click at the bottom, create a copy. So the advantage of doing that is that you preserve what you just solved, and you can use it as a starting point for your next part of the calculation. So doing that here, I've still got, all the same cash flow table. The function is set up. All I have to do now is the what if analysis. So we're looking for what is the interest rate that gives us the sum equal to 0. So if we do here on the data tab, what if analysis, goal seek, for the green being our target, objective, set it to 0 by changing the interest rate. Go ahead. We find what looks like 7.63%. So that's the internal rate of return. Did anybody else also get 7.63%? Good. Now, there's a built-in function called the internal rate of return function in Excel. So let me show you. It gives you little hints once you start typing it, just like all the functions do. So if you do equals IRR and then parentheses, it'll tell you to put in values. That's not as helpful as we'd like, values. So the values you should put in are just the amounts. Don't put in the present values of the amounts. Put in the original amounts that you keyed in. And what it's going to do is it's going to find out what is the interest rate that, when all of those amounts are discounted to the present at the interest rate, has equilibrium between the inflows and outflows. So it basically is in the background doing everything that we just did step by step in the foreground. So it says 8%. Well, how come it says 8% if we found 7.6325067%? Why does it say 8? Yeah, we just got to show more digits. So here on the Home tab, under the number area of the ribbon, if you increase the decimals that are being shown, we'll get the same level of precision as we were calculating the other way around. Okay, so that's the IRR function. On the homework, I tell you to solve for the IRR using like the full illustrated approach. That means do it this way. But then if you want to check your work, you can use the IRR function. But I need you to get the practice and find out the process here, doing it manually for that problem on the homework. Any questions about problem 2 or 3? So that leaves you with 5 minutes to value this bond. You want to find out the annual yield of 12%. What price should you pay if R times Z is $50 and give you a lump sum payment of $6,000? So C is $6,000, R times Z is 50, 5 years times 12 months per period, 12 months per year. You should be able to value this bond in 4 minutes. Okay, so I is 1%, N is 60, R times Z is the interest amount, 50 per period, 6,000 redemption. So that means the lump sum component of the present value is 3,300. The present value of the interest payments is 2,247. So the combined value, 55.50 and 45 cents. All right, that's it for today. I'm letting out 1 minute early. You're welcome. I'll see you on Friday.
Look at the seconds.